Let's look at one more thing here. Let's look at current nodal. Current nodal, right? Can I use current nodal here? Yes, okay. I'll start off first by consolidating these two series resistors and making one equivalent resistance of 3K. Now I got to turn this voltage source into what? Current source. Okay, so I'm going to turn it into current source. Which direction is the arrow pointing? Okay, and my resistance on that branch is 3K with a 15-volt source. What current is that going to give me? 5 milliamps. What do I got to do with that equivalent resistance value? Shunt it. I'll call it REQ1, 3K. I'm going to slide this one, because it's parallel, into the middle. And then I'll combine those resistance. I'll call it REQ2. And that's 8K. Now what about this voltage source? What do I got to do with it? Okay, which direction is the arrow going to point? Down. And that will be IS2. What's the value? 3.75 milliamps. What happens to that R4 resistor? Shunts it. Okay, now what do I do? Combine all the resistive values. Okay, what's the easiest way to do that? Just do product over sum, product over sum. All right, let's do product over sum here first. We get 8K times 4K over 12K, which is going to be 32K squared over 12K. What does that give us? 32 divided by 12? Should be 3.75. Is it 3.75K? Is that right? 2.66. 2.66. Yeah. Okay. Close. 2.66K. Yeah, 24 is 2. Okay. So I can erase those. 2.66K. Now I can do product over sum again, yes? What do we get for that product over sum? 1.4 K ohms. Just 1.4, that's it? 1.41. 1.4176476. Okay, what do I do now? Draw my currents? All right. Coming out of IS2, I've got 3.75 milliamps. That's going this way. Coming out of IS1, I got 5 milliamps. That's going that way. Well, I need 3.75 to go into IS2. What happens to the remainder? It goes down across the 1.1441, right? And how much is that? 1.25 milliamps. So what's the voltage for that equivalent resistance value? Call it REQ3. What's that? 1.76 volts. It's 1.76 volts. Right? And because the current's going down, what's that voltage value going to be? It's going to be negative. Okay? And now we see that that is exactly the same as the other voltage values that we've already solved for. Any questions on current nodal? Yes?
How would you determine that?
Because I've got 5 milliamps going into that node, right? How many milliamps is going to IS2? 3.75 milliamps, okay? So that leaves me with 1.25 milliamps left, right? It's got to go somewhere. It's going to go down. So that's how you determine that. Does that answer your question? Outstanding. Any other questions? Okay, so we see that if we're asked for voltage nodal, there's a variety of other ways we can do it. If we're asked for voltage Millman, there's a variety of other ways we can do it. If we're asked for current nodal, there's a variety of other ways we can do it. If you're asked for Thevenin voltage, you got to find Thevenin voltage. There's only one way to do that. Same with Thevenin resistance.